So when I use Voronoi fracture in Houdini, the input you gives is a base geometry with a point where the Voronoi center would be, and it itself is really useful for many purposes, but I had one issue using it, that I had a task that I wanted to make the edge of the Voronoi to be really straight line. Right now, when you use Voronoi fracture node, the edge that its node gives is really a curved polyline, but I wanted to have this line, the curved polyline, to be straight line, and I thought it was easy to do, but it wasn't that easy when I tried to do it, so I'll left a note how to make those edges a straight line in this video. So here's how to do it. First, let's make a sample geometry with a curved surface, or so that it will be a good example. So I'll just make a sphere and set it to primitive is fine, and I'll give a scatter, and for this scatter point I'll just make a 4 points, and let's set the global C to something like 0.29 or something, and I'll give a metavol copy to its point. Like this. And the metavol size is a bit small, so I'm gonna give this size a little bit bigger, maybe like this. Yeah, looks good. 0.4, 1.4, and I'll just convert this metavol, meta convert to polygon to use it for Voronoi, and the default parameter is good. Now let's have some points on the surface, on the mesh, on top of the mesh, to use for the Voronoi. Something like 200 or 150, and give a Voronoi fracture. Like this. And let's visualize the piece so that I can see its edges. Okay. So what I want to do is that I would like to make the edge of the Voronoi on the surface to be straight line. So in order to do that, first what I want to do is to give each point a ID for the scatter point. So I'll give a point wrangle and to the ID attribute I'll give a point number. Let's name it feed ID. If I look at the geometry spreadsheet, yes, I have it. Okay, and I want to transfer this attribute to the primitive of the Voronoi. So I'll turn on the copy cell point attributes and to piece point. Yeah, the piece points is fine. I'll transfer ID, and if I look at the attributes of the geometry on the point tab, I got ID on each point, which is related to each primitives, each cells. Now it's fine. Now, first thing I would do, let's make a edge. Let's extract the edge of this Voronoi fractures first. So in order to do that, I will first use the carve to get the inside. I mean, take off the inside and just get the outside group. So right now I already have the outside geometry here. Okay, now next let's normalize it to normalize the mesh. Then I'll use what I want is the edge of each cells. So right now the problem is that right now each cell has like unnecessary edges, so I want to delete that. So I'll use divide component to get rid of that. So if I use the if I check the remove shared edges, it will just remove the inside edges and get only the naked edge. And last of all, carve again to just get the outline. Okay. Now I seem to have an inside geometry as well right now. I want to get rid of that as well, so I think I'm missing something. I think what I need to do is I'll go to the first carve and I'll give it an extract. Yeah, something like that. And extract point, well, I think this is fine. Let's give it extract points. Okay. Now I have the curved edge, the edge of the Voronoi, but it's still curved. So I want to make it straight. In order to do that, at this point, let's give a fuse to make it clean. And I need another information for it. Which is a point information for each connected, like networked position of. So which point? So right now I have tons of points here, but I only need the point on the connected position for each cells. So in order to do that, first I'll attach a delete node to the Voronoi, and I'll delete the outside. group. Okay, then I'll make a point wrangle. And if I look at the geometry, I have tons of points. But what I want is the point which has a neighbor that is more than 2 connections. So if the connection is less than 2, then I would want to remove it. So in order to do that, I'll look at the neighbor counts for each point. And neighbor count equal neighbor count. Then if the neighbor count is less than 2 or equals to 2 as well, remove the point at this point number. Now now I have the edge point also, but I still have the points on the inside of Voronoi fracture, so I also want to get rid of it. So in order to do that, let's first delete the primitive. And primitive, keep the point. Now I have all the points here. Okay. Now let's compare this point with these. And these points are only on the surface, but these points are that includes the straight line point, the point that makes a straight line, but also it's inside a geometry. But if I compare these two, I can get what I really need, only the straight line points which stick to the surface. So I need another point this time it's primitive wrangle. And I'll connect the fused points on the first input and the deleted points on the second input. Then first make a new points array, and which will be a points for each primitives. And I also need to make a new array to have information which points should be deleted from this list of points. So what I need to remove the points on the edge which is not on the corner to make it straight line. So let's go through all the points inside each primitive. PT equals PTS I vector position equal point ID equals to point and I'll get the count for the reference point, which will be I'll look at all the IDs. So the point from the delete has a attribute of ID and points, and this one also has the ID, and so I need to compare those two to see how many points you have on the second input compared to the first input. And give a temporal number, temporal boolean. Well, there's no boolean vex, so I'll just use integers, 0 and 1. And for int n equals n to ref pt count and ref pt will be used to find attribute value to actually get the point ID, which have the similar ID with the input 1 and input 0. And get the position of the reference position. And now compare the distance between the each point of the primitive points from here to this one. So if the points, let's say the primitive one is this one, and if the point on the surface on the primitive is really close or exactly on the same position, then keep that point, and if the distance is really far, maybe farther than 0.01 or something, then delete that. So I need to calculate the distance between the first point and the second point. Then if the distance is less than 0.001, could be smaller, then don't delete, which means it's on the same position. But if not, then delete. Keep the del to 1. So after doing this, if the delete is 1, then add a delete position pt to del pts, I mean delete point index. Then finally go through all the point index inside the del pts array. Maybe I should write like this, looking from the end, because I want to delete those points, so I don't want to mess up the array. Right. And get the del pt index. And remove point at del PT. And I have an error somewhere. Spell mistake. And I still don't get anything here. Maybe I'm missing something. Okay, maybe I deleted everything that I shouldn't delete it. Okay, yeah, seems like so. Okay, so this is a primitive wrangle, right? Yeah. And deletion is 1 if the ref point counts, plus. And find attribute value. Wait a minute. It's not points. It's point. Okay, what would happen if I do like this? Okay. Now I got it. The thing is that right now it's open polyline, so and at the end of this one I need to give a end to actually close the polygon. And that's it. No, it's not closing it correctly. I need to close the U, close U to close straight. And that's it. Yeah. It's hard to see if it's straight or not, so I'll give a same color as the Voronoi fractures. So the Voronoi fracture color is 5 packet. Does it give me a color value? Nope. Transfer the color. Now I have this color value, so I'll use this to transfer it to the... Wait a minute, but it already have a color here. Maybe I should normalize. Okay, that's it. So, this is how you can convert the curved edge to a straight edge, which might be useful in some cases. Okay, thank you.